Assalamu alaikum. Today's lecture is about Bitcoin and blockchain. Okay, we will start with what is a Bitcoin. We can say that Bitcoin is a cryptocurrency or a software-based online payment system which was invented in 2008 by an unknown person, Satoshi Nakamoto. This is the name that is being used by that person, and it was introduced or implementation is available as a open source software in 2009. Bitcoin is a decentralized digital currency without any central bank or a single administrator, and it can be sent from user to user by on the peer-to-peer Bitcoin network without the need for any intermediaries. Transactions are verified by network nodes through cryptography, and all the information or payments are recorded in a public distributed ledger, and this public distributed ledger is called a blockchain. Bitcoins are created as a reward for the process known as mining that we will discuss in the coming slides, and these bitcoins can be exchanged for other currencies, products and services. You can use it to buy anything, sell anything, or exchange it with the other currencies as well. So in that way it is not different than any conventional dollar or any conventional currency. We commonly refer Bitcoin as a cryptocurrency, and it can be divided into smaller unit called Satoshi. Like, you know, when we talk about Omani Rial, when we divide into smaller unit is Paisa. Okay, 1 Omani Rial is equals to 1000 paisas. So one bitcoins can be further smaller unit divided into smaller unit called Satoshi, which is 100 millionth of Bitcoin. Okay, what Bitcoin is based on? This system is run by the protocol called Bitcoin protocol. What is a Bitcoin protocol? It is a distributed ledger that maintains the balances of all Bitcoin that are trading in the market, and these ledgers are massive files which stored on thousands of computers around the world. So the network record each transaction onto these ledgers and then propagate them to all of the other ledgers on the network, and once all of the network agree that they have recorded all of the correct information, then the network permanently confirm the transaction. Before that, transaction is not confirmed. So it's all based on mathematics. It's not like conventional currencies which are mostly been having a fixed quantity of metal based on quantity of metal like gold, silver or fiat currencies. Bitcoin is based on cryptography and mathematics. It has several features that make it different from normal conventional currencies. First is it is decentralized. All our other currencies are centralized, but Bitcoin is decentralized. It is easy to set up and it is very fast and efficient. It is anonymous. That is a very basic feature of Bitcoin. Like if somebody is buying or selling something through Bitcoin, you cannot trace that person back. You can do anonymous payment through Bitcoin. It is completely transparent. There is no chance of any fraud. Transaction fee is really very small. And another feature of Bitcoin is transactions are irreversible. Like, you know, if you do transaction through credit card or PayPal, you can reverse your transaction. But in case of Bitcoin, once you make a transaction, you cannot reverse it. Okay, first property of Bitcoin, as I told you, that it is decentralized. So when we say it is a decentralized, then it means that the Bitcoin protocol is based on peer-to-peer system instead of client server. You know, client server is a centralized system, but Bitcoin is a peer-to-peer system, and there is no need of any central body or third party to verify your transaction. So it is not controlled by any central authority. It is fully decentralized system. Bitcoins are created by a community of people that anyone can join, and there is no authority or financial institution which can tinker with monetary policy and in that sense devalue or revalue Bitcoin currency. What it means by monetary policy? Monetary policy is the macroeconomic policy which is proposed by the central bank, and it involves management of money supply, interest rate, and is the demand side economic policy used by the government of a country to achieve macroeconomic objectives like inflation, consumption, growth, and liquidity. But in case of Bitcoin, there is no such monetary policy that can affect on the rise or decrease in the price of Bitcoin currency. It is fully decentralized. No central bank can control Bitcoin. It's anonymous and transparent. So Bitcoins are stored in a special wallet which is called Bitcoin wallet. So Bitcoin wallet is a software program, and technically Bitcoins are not stored anywhere. For every individual who has a balance in a Bitcoin wallet, there is a private key that is corresponding to the Bitcoin address of that wallet. So and we have 4 types of Bitcoin wallet, which are desktop, mobile, web, and hardware wallets. Now for each wallet the owner have 2 keys, public and private key, where public key is the considered as equal to the account number or account name, and private key is equal to or is used to show the ownership credentials. When Bitcoin is transferred to the next owner, then that next owner gives a public key. Like when you are going to transfer a money from your account to another person account, you would need the bank account number of that person, account name and account number of that person. In case of Bitcoin, when you want to transfer money to some other person, you will need his or her public key, because public key corresponds to the account number or account name. Okay, so you will get the public key of that person, and the previous owner, the owner who wants to transfer money, will use his private key to publish a record into a system, that is a distributed ledger system, where he announced that the ownership of his Bitcoin has changed to the new public key. Got it? It is same like you are transferring money from your account to another account. So when you are transferring money from your Bitcoin wallet to another person Bitcoin wallet, you will need his public key, and you will use your private key to transfer your Bitcoin to his account or to his public key, because public key is like a account number or the name of the account. And all the transactions that are being held through Bitcoin, the detail of every single transaction is stored in a huge big distributed ledger which is called blockchain, and anybody can verify these transactions. So all the transactions that are done through Bitcoin, the information of all those transactions are stored in a distributed ledger called blockchain. So what is a blockchain? Blockchain is the distributed ledger which keep record of the transaction held through Bitcoin. Okay, Bitcoin transaction have very small transaction fee which is almost negligible, and process is irreversible. Bitcoin is not the first digital currency, or not the first private money, or not the first currency that is based on cryptography, but we can say that how Bitcoin is different from other private money or digital currencies or cryptocurrency is that it is based on peer-to-peer network which is decentralized, and this decentralization is used to avoid double spending. Double spending mean you cannot spend a same Bitcoin more than once. Like once you spend, it has been gone from your wallet to another person account. Okay, how this double spending is being avoided by using Bitcoin. In Bitcoin, each and every transaction has to be first verified before adding it into the blockchain, so that we want to make it sure that input of the transaction had not been previously already been spent. Okay, so it helps us to avoid double spending. How double spending is avoided? Because each and every transaction is verified before adding it into the distributed ledger or blockchain. Okay, how bitcoins are created? Bitcoins are created through a process called mining. Okay, what is the mining process? In mining process, the miners participated. Okay, what are miners? Miners are special computers which use special software to solve a very complex mathematical problem which we called Bitcoin algorithm. And once they solve this problem or complete the task, then as a reward they receive Bitcoin, some amount of Bitcoin. So by the process of mining, you can earn cryptocurrency without having to put down any money for it. You just have to participate in the network as a miner. Once you solve the mining problem, you will be rewarded with the Bitcoin. Okay, and you can receive it without any investment on it. So Bitcoin miners receive Bitcoin as a reward for completing block of verified transaction which are added to the blockchain after this mining process has been completed. And mining process is the only way to release new cryptocurrency into circulation. So you can say in other words that miners are basically minting currency or creating this currency. For example, as of November 2020, there are around 18.5 million bitcoins are in circulation. And if we consider aside from or beside the coin that are minted via the Genesis block, Genesis is the very first block which was created by the founder Satoshi Nakamoto. After that, every single Bitcoin that is came into being is coming through because of these miners. These miners created these Bitcoins. Aside from the Genesis block Bitcoins that were created by the founder Satoshi Nakamoto. So if in the absence of miners, Bitcoin as a network would still exist and be usable, but there would never be any additional Bitcoin that are being created. Okay, and there will eventually come a time when Bitcoin mining ends. As per the Bitcoin protocol, the founder of this currency, he put a special cap on the number of Bitcoins that can be there in the world. The total number of Bitcoin will be stopped at 21 million. Okay, once 21 million Bitcoin has been created, then through mining process no more Bitcoin can be created out of it. Mining process will still be continue, but as a reward for miners, the transaction fee will be paid by the one who wants to do that transaction. And then there is another thing, is the rate of block creation is approximately consisted over time, that is 6 blocks per hour, or we can say 1 block every 10 minutes. After every 10 minutes, one new block is added into blockchain, and this rate of block creation is reduced 50% every 4 years. If we go through this, okay, this diagram, it shows that the reward that is given for Bitcoin miners are reduced every 4 years. Like when Bitcoin was first mined in 2009, then miners after mining one block earn 50 Bitcoins. Okay, but after 4 years in 2012, this was half to 25 Bitcoins. Okay, and then in 2016 again it has been half to 12.5 Bitcoin, and in 2020 now it has been again half to 6.25 Bitcoins. So after every 4 years miners reward become half. So in this way they said until 2140, when total number of Bitcoin reaches to 21 million, then no more new Bitcoins will be created using mining process, and mining reward will reaches to 0. Okay, but miners still work, because now they will charge after 2140, they will charge their mining fee from the transaction owners who want to do transaction. They will pay they will pay for it. Okay, right now the reward for miner is by for adding one block into blockchain, they get a reward of 6.25 Bitcoin, or 6.25 Bitcoins are added into the network of Bitcoin. Now how much is the value of this 6.25 Bitcoin? So as per November 2020, 1 Bitcoin is equals to $17,900. So if you are earning 6.25 Bitcoin, then you are earning 111,875 dollars for mining one block of Bitcoin, which is again a really big money. Okay, this diagram shows us the number of Bitcoins that are in circulation along with the period. Like as we know that creation of Bitcoin become half every 4 years, like mining reward become half, so less number of Bitcoins will be added into the currency overall market, and when we reaches to 2140, then no more Bitcoins will be created after that, because we have reached to the upper limit, that is 21 million. So after that there is no more Bitcoins added into the currency. Okay, if we want to see how many Bitcoins are there in the world right now, so we know that total Bitcoins that can ever be mined is equals to 21 million. And currently, as per 25th November 2020, total Bitcoin that have been there in existence are around 18 million, or 18.5 million you can say. Okay, how many new Bitcoins are created per day? We created per day 900 Bitcoins. Okay, how this 900 value is being created? As we know that one block is created every 10 minutes, and in 1 hour we created how many blocks? 6 blocks per hour. So in one day we created 144 blocks. How we can get 144 blocks? 6 multiplied by 24. In 1 hour we created 6 blocks, and in 24 hours we created 144 blocks, which is 6 multiplied by 24. So 144 blocks are mined per day on average, and there are how many what is the reward for creating one block? 6.25 Bitcoins are rewarded per block. So how many total blocks are created per day? So 144 multiplied by 6.25, which is 900. So on average 900 Bitcoins are created per day nowadays. Total number of blocks that have been mined until now are 658,581, and Bitcoins that are left to be mined are around 2.4 million, and total number of Bitcoins that have been issued until now are around 88%. And what is the value of Bitcoin? Oh my god, one Bitcoin is equals to 7,372.98 Omani Riyal, or equivalent to $19,150.10 as per today's 25th November 2020 value for one Bitcoin. How you can get a Bitcoin? Is it necessary to be a miner to get or earn Bitcoin? No, but one of the way to earn Bitcoin is through mining process. Okay, but you can also earn Bitcoin by accepting them as a mean of payment, like you are selling something, and for price, instead of receiving dollar or Omani Real, you said that give me payment in Bitcoin. Okay, so you can earn Bitcoin by that way, or you can earn Bitcoin through trading, or as a regular income, or you can even buy it in the from exchange. Like, you know, you go to exchange, and if you want to buy dollar, you give real, they will give you dollar. So same is, there are exchange for Bitcoin where you can pay with any currency, any fiat currency, and you can get Bitcoin as a exchange. So there are various ways you can earn Bitcoins. Okay, what is the Bitcoin network? Bitcoin network consists of nodes that contain the processing copies of a public ledger called the blockchain. So blockchain is a huge distributed public ledger which keep record of each and every transaction that is occurred in the network of Bitcoin. So every time a Bitcoin is spent, a transaction is generated as a result of this, Bitcoin spent, and then this transaction is recorded into the blockchain as a block. One block contain many transactions inside it. So, and these transactions are then verified in a block through a process called mining process. And once this mining process complete, it means that the transactions inside this block has been verified, and then this block can be added into the blockchain, which is a huge public distributed ledger. And these transactions are broadcasted throughout nodes in the network, and anybody who is the part of this mining network can participate in this mining process. And after every 10 minutes a new block is generated, and the miners who generate this block will get as a reward 6.25 Bitcoins. And as we know that it decreases over time, after every 4 hours this will reduce to half. Bitcoin network is the you can consider it as the largest distributed supercomputer in existence, and it is growing with time. You know, when more and more people are added into this network, miners are added into this network, this distributed supercomputer power is increased. The hashing power is because these miners need to solve a complex mathematical problem based on this hashing algorithm. So the hashing power of the miner is estimated from the number of blocks being mined in the last 24 hours and the current block difficulty. Like right now, in one day, total number of blocks that are being mined are 900 blocks. 900 Bitcoins are generated. Now, in how many blocks are created depends on it. How many transactions are there in one block. So, what is the hashing power is based on the number of blocks being mined in last 24 hours and the block difficulty, current block difficulty, because each block, this complex mathematical problem has a certain difficulty to solve it. So what is the current difficulty of this block level, that and number of blocks that are being mined in last 24 hours. So the hashing power depends on it. So the formula for hashing power, you can say it is 2 raised to the power 32 multiplied by d divided by t, where d is the difficulty of the current block and t is the average time between mined blocks, like how much time it takes to mine, average time to create to mine a block, that is t. So hashing power is calculated using this formula. As we know that blockchain is a distributed ledger, so here I will explain a bit concept of what is a distributed ledger. Okay, here in this side we show a centralized ledger, and this is the distributed ledger. Now in centralized ledger there must be a centralized party or central party, like here we show the bank. Bank is a centralized party, and in distributed ledger there is no any centralized party. All nodes are equal, like node A, B, C, D. Now in case of centralized ledger, there are multiple ledgers, like client A have its own ledger, B has its own, D has its own, but bank has the golden record or all the records that are present in the ledger of A, B, C and D is also present in the bank ledger. So if let's suppose client B want to verify any of its transaction or its ledger entries, it must reconcile its own ledger against that of the bank, and must need to convince the bank of the true state of the bank ledger if any of the inconsistency or discrepancies arise. But in case of distributed ledger, there is just a one ledger, not a many ledgers. Like in centralized ledger, there is only a one ledger and each node have the same copy of that ledger. Like node A ledger and node B ledger will be same. So all nodes need to agree to a protocol which determine the true state of the ledger at any point of time. Like if you want to find out all the transaction are in the ledger are authentic and verified, so in order to do that, there is a special protocol that is used to determine this true state, and the application of this protocol is called achieving consensus, or like in Bitcoin in the blockchain, this is proof of work is the protocol that is used to achieve the consensus of this distributed ledger that has every node has a copy of it. Okay, now this diagram give us the idea of the blockchain transactions. Now let's suppose this is Alice. Okay, this transaction previously is done by Alice, and this is Bob, and now Alice want to send some money to Bob. Okay, let me change, the color is not good. Okay, this is Alice and this is, let's suppose, Bob, and now Alice want to send some money through transaction to the Bob. So how will Alice perform this transaction? How transaction look like? First of all, for this transaction, because Alice want to send money to the Bob, she will need Bob's account number. What is the Bob account number in Bitcoin or in the blockchain technology? It is Bob's public key. So it will need Bob's public key or owner's to public key over here, and then a hash is calculated using this public key and previous transaction, whole previous transaction that is used over here to spend the same Bitcoin, that will be given as input to this hash function. Hash will be calculated on it, and then the output of this hash will be signed by or will be encrypted by the Alice private key, because Alice want to send this money to the Bob. So Alice will use her private key to sign this public key of the Bob and previous transaction and any of the content of the current transaction. A hash will be calculated on it, and then Alice will perform her signature on it, and this signature can be verified at any time using the Alice public key. And now Bob want to transmit this money to somebody else, like here another user C. So Bob will use his private key to sign the public key of the third user C, and hash will be calculated on this public key, content of this transaction and the previous transaction will be also given as input to this hash function, and then will be signed by the Bob private key, and so on. So this way these transactions are chained together. Okay, so this is called blockchain transaction. Now this diagram shows us the blockchain architecture. Now in blockchain architecture, we have different blocks which are chained together. Like here this show, they are linked together. Okay, how this link is created? A link is created in such a way that when we create block 2, we added block 1 hash on block 2. When we created block 3 has the hash of the block 2. So this link is created by calculating the hash on the previous block. Okay, now what are the contents in one block? Like let's suppose if this is block 1, so here we show the content of block 1. Now look at the contents. One block contain many transactions. Okay, one block is not consist of one transaction. in the previous diagram I show you blockchain transactions. Okay, so when multiple transactions has occurred, so then a one block is created out of it. Okay, so one block consists of multiple transactions, like here we show transaction 1 2 3 up to transaction n. So we have multiple transactions on one block, and then that is the transaction counter, and the number of transactions are there in the transaction counter, and then all the transactions are over there. And then we have a block header. Block header have further some data into it, like this current block hash, a nonce. Nonce is a random number that is generated, like a new random number for every different block, a new nonce is created, and previous block hash. Okay, this is block 1, so it contains the hash of block 0, let's suppose. If we look at the contents of block 2, you can see here that this block 2 have its own hash, its own nonce, and previous block hash. Which is the previous block? Block 1 hash. It creates the hash of block 1 and its own set of transactions. When we create block 3, it contain the hash of the block 2 and its own set of transaction, its own hash and its own nonce. So these blocks are chained together with this hashing function, like each block contain the hash of the previous block. Now the purpose of this hash is, like if somebody, let's suppose we assume that an attacker changed some of the transaction contents over here. Let's suppose if somebody changed some of the contents of this transaction. Okay, when contents of this transaction has been changed, and this block, this is the hash of this block. Okay, so when we verify this, okay, previous block hash over here, when a hash is being calculated for this change transaction, this hash and this hash will not match. Both hashes will not match, and you know you have inconsistency in this blockchain. So anytime if there is any modification in any of the transaction, that can be verified through this previous block hash chaining thing, because each new block contain the hash of the previous block. So if you make change over here in this block, you not only have to change this block hash, but you also have to make change over here in this previous block hash and all the previous blocks. Okay, now what is a block in blockchain? We can define block as a collection of Bitcoin transactions that have been added to the blockchain, or a block is something that contain a list of transactions, because when you make a Bitcoin transaction, it is not added to the blockchain straight away. Instead, it is held here in this transaction pool, or you can say memory pool. And if you are a miner, your job is to gather transaction from the transaction pool into a candidate block. Like you choose transactions from here in the transaction pool, and then you create a candidate block and try to add this candidate block to the blockchain. Now when candidate block will be added to the blockchain? Once the miner complete the mining process. And how to complete the mining process? When miner will solve the mining problem. Okay, first the one who will first solve the mining problem will win this mining process, and then a block will be added to the blockchain. Okay, when this candidate block is being created by the miner, then it also add a block header with this candidate block. Now what is a block header? Block header is actually a metadata about the block. Okay, we can show over here. Okay, what is there in the block header? Now block header has different information. Okay, the size of overall block, one block in Bitcoin network is 1 megabyte. One block size in Bitcoin blockchain network is 1 megabyte. Out of 1 megabyte, we have 80 byte of header, and rest is all the transactions. So if we have just a size of block header without any transaction, the size of block header is 80 byte. Now there are different fields in block header. First is the version. which gives us the information about version of the block. Version number describe the structure of the data inside the block, and this is used so that computer can read the content of each block correctly. Then we have a previous block ID, which is identification number of the previous block. We are trying to get one of these for the current candidate block. And this is very important, previous block ID, because this is what chain the block together. As you know that each block contain the hash of the previous block. So previous block ID will give you this idea that you have to add the hash of the which previous block on this current block. Then Merkle root. Okay, this is very important field in the block header. Merkle root is calculated where all the transactions inside the block are hashed together to form a single line of text, and all of the fields are unique, but it would be fair to think of this as the most significant part of the block header. We will discuss this Merkle root in more detail in the coming slides, how it is calculated and what is the significance of this Merkle root. Time is the current time, and then we have bits, that is related to the target, a value that a miner work with to try and add candidate block to the blockchain. So this also we discuss in the coming slide. And nonce is also a field that is related to this target, that is this field miner will change in order to try and get the hash of the block header that is below the target. So it is related to target. We will discuss it in the coming slides in more detail. Merkle root, that is a very important part of the header of the block, okay, that we write over here, Merkle root. Now what is a Merkle root? We can say that Merkle root is a fingerprint for all of the transactions in a block, or it contains information about all of the transactions in the block. Now how this Merkle root is created? This Merkle root is created by applying the Merkle tree on all the transactions, or calculating the Merkle tree out of all the transactions. We do not need to store all the transactions information on the block. Instead we store Merkle root data structure on it, which save the space as well. Okay, how Merkle root is created, or Merkle tree is created out of the transactions. Okay, Merkle tree, this is an example of Merkle tree. Like in the block we have a list of transactions, transaction A, B, C, D, E, F, G up to H. Then we calculate the hash of each of the transaction. Okay, transaction A hash is the hash A, transaction B hash is the hash B. So we the hashing start at the lowest level or leaf level nodes, which are your transactions, and then we pair these hashes together, like hash A and hash B is paired together, and we calculate hash of A, B over here. Similarly we pair C and D and we calculate hash of this pair, hash CD, and similarly for the other, and then we go up level by level and we combine them in a pair and calculate hashes of them all together. And when we come over the root, this is the root. Now this is the hash of all the transactions from A up to H. So this is a Merkle root, Merkle tree root, that is stored in the header of the block. And this root contain all information about every single transactions hash that exist on the block. So it offer a single point hash value that enable validating everything that is present on the block. So when we want to validate any of the transaction on this block, that can be validated through this Merkle root. Same concept is explained over here, like this is a block and this block consists of multiple transactions. Okay, Merkle tree always group all the data input into pairs. Like here in this case, if there happen to be odd number of input, like transactions are odd number of input, then this last input is copied and pair with itself. Okay, and this applied to all the transaction IDs that are written into a block in a blockchain. So we just pair them together and create their hashes, and then these hashes are further paired together and create hashes on the next level until you reaches to the top level, where the top level is called the Merkle root, which contain the information about all the transactions in the block. Now the question is, why do we use a Merkle root? Why not we just create a straight away hash of all these transactions together and create one simple hash? We join all these transactions together and create one single hash out of it instead of Merkle root. Now let's suppose if we do something like this, instead of creating a Merkle root, if we create simple hash and we want to verify any of the transaction, like we want to know if this transaction is included in the hash or not. Now how can you do so? You need all these transactions together, and you have to recreate the hash of all the transaction and then compare it with this hash, and if both hashes are same, then you can verify that this hash is this transaction is included in creating of the hash, simple hash. For this verification, you need all the information about all the transactions. Okay, now if we consider same scenario here, if we want to verify that this transaction is included in the hash or not, now we will consider Merkle root or Merkle tree structure. Like instead of this simple hash, if we create Merkle tree, then how many transactions are required to verify any of the transaction over here? Let's suppose we want to verify this transaction, so we will need only this transaction, only one more transaction over here, and from these two transactions we can create this hash. Now we have this Merkle tree. Okay, we can create this hash and we verify it with the Merkle tree that is already present. Okay, if both are same, okay, fine, then we will recreate this hash, and then we will recreate this Merkle root and compare on each level, and we can verify any of the transaction. So in that case, when we have Merkle root, we can verify any of the transaction on the block by we just need one more other transaction on it, not all the transaction. Like here in this case, we need, whenever we want to verify any of the hash, we need all the transactions on this block to verify this hash. But in case of Merkle tree, this can be done we just need one other transaction over here to verify this transaction. Okay, when are Merkle tree useful in Bitcoin? Merkle trees are very useful in Bitcoin, and when it is very useful, because when you want to confirm a past transaction, if we do not use Merkle tree, then a node would need to reach out to the network in order to get copy of the ledger from its peers, and then it has to download all the blocks of the blockchain in order to verify any of the transaction. So and it required to download a huge amount of data, and then for verification have to do a lot of work. But if we are using Merkle tree, then this verification of transaction can be done simply. Like in for this, thin nodes are used. Now what is a thin node? Thin node is it is a type of Bitcoin wallet software which does not operate as a peer-to-peer network node to download the complete blockchain ledger. Instead, it just track Bitcoin transaction by querying a single server on the Bitcoin network only for the transaction that involve the address in its wallet. Like this is a thin node, and thin node only does not store full blocks, because if it is going to store full blocks, it takes a lot of space, like some gigabytes of space is required to store full blockchain. So instead of storing full blockchain, it only store the block headers, and block headers create Merkle root of each Merkle tree of each block. So if it wants to verify any of the transaction, what this thin node can do is it can query this full node and ask this full node to send the block header, transaction ID and Merkle proof over here, and then can verify this transaction easily through this Merkle root tree. Block header bits is one of the field in the header of the block that we already discussed. Like here, you know, if you look at the block header, there is one field name bits. Now what is there in the bits? Bits field is an important field which is related to the target, okay, target value. So we do not store the complete target value in the block header. Instead we store the compact form of the target in a special format called bits. Okay, so this bits field consists of 4 bytes, where first byte is called exponent, and rest of the 3 bytes are called coefficient. Now exponent gives you the size of the target in bytes. Like here, exponent is 1/8 in hexadecimal, so 1/8 when we convert it into decimal, it is 24. So it tells us that our target size is 24 bytes, and this 06965F4, the next 3 bytes are the first or the initial 3 bytes of the target. So instead of storing the whole value of the target into the block header, they store it in just 4 bytes. Instead of 24 bytes, they just store same information in 4 bytes over there in the form of bits. Its hash value here is 2ZB1, and it also contain hash of the previous block. If it is the first block, then we assume that there is no previous block over there, so previous hash is 0, like let's suppose. Okay, when we go for block 2, block 2 has its own hash value, and it contain the hash of the previous block, and so on. So same thing goes on in all the blocks, and this way these blocks are linked together or chained together. That's why we call them blockchain. Now here we assume that there is an attacker who attacks on block 2 and change some transactions in block 2. When he make changes in block 2, it means the previous hash is no more a valid hash. Its hash has been changed, so he recalculates the hash of block 2 after making changes into it, and let's suppose the new hash is AA23, but block 3 contain the hash of the block 2, and on block 3 hash of block 2 is still the old hash. So the attacker then have to make changes into hash. Here in the previous hash, it has to update it to AA23, but when attacker update this hash, then it means that the existing hash of block 3, which is this value, is no more valid now, because if it change this 7B2Z to AA23, like let's suppose it change it to AA23, then attacker has to, then after changing this hash value over here, this hash no more become valid. Now he has to recalculate the hash of block 3. Okay, now when this hash 3 block has been changed, then block 4 contain the hash of block 3, so he has to make same changes to block 4 and all the coming blocks after block 2. So if there is a changing in a single block, it can quickly make all following blocks invalid, and if attacker don't want anyone to come to know about these changes, he has to make changes to all the subsequent block after the block where it makes changes, which is really a lot of hard work. So that's why the record transactions once entered into the block of blockchain, it is very hard to manipulate or change it. As I already mentioned, that what is a blockchain? Blockchain is really a huge file, which we also called as a distributed ledger, and each node that is participating in the Bitcoin network or blockchain network have a copy of this blockchain. So we can say that it is a file that contain a list of every Bitcoin transactions ever made. So anybody who has ever made any transaction through Bitcoin, the record of that transaction will be present in the blocks of the blockchain. and anyone can verify these transactions. What is needed to verify these transactions? Just a person who wants to verify the transaction has to download the blockchain all blocks, and then they can verify it. And this also gives information of how many bitcoins each person owns, because everyone on the Bitcoin network share a copy of this blockchain. Everybody have a same copy of this blockchain, and every time when a new transaction occur, this blockchain is updated regularly. Proof of work. Proof of work is the algorithm that is used during the mining process of Bitcoin. What is a proof of work? The basic idea of proof of work is taken from a paper that was written in 2002 by an author named Adam Bax, and he proposed an algorithm that is called Hashcash algorithm. Okay, the Hashcash algorithm basically was proposed to prevent distributed denial of service attacks on the network, and also it is used to identify the spam emails, because spammers, they generate a large number of spam emails, so these malicious user can be easily identified by using this Hashcash algorithm. So proof of work is taking its main idea from the Hashcash algorithm. Hashcash algorithm use a cost function as an anti-DOS mechanism, and it require malicious party to use a lot of processing power of their devices as a proof of work. So as I told you, it is used to detect spam emails. So if there is a regular email user, this would not present a challenge for a regular user. However, for malicious user, it would be a great challenge. Why? Because a normal user is just going to generate a single email, and it has to perform this proof of work on the single email. It's fine for them, and they can do it by using a normal laptop or desktop system with normal CPU power. But for a spammer, this is really a hard work, because they want to send like 10,000 plus emails per minute down a negligible, but because you are sending so many emails, so it adds a lot of processing work to do this proof of work or Hashcash algorithm on these 10,000 plus emails by the spammers. But for regular user, it's not a big deal. A basic Hashcash function uses SHA-1 algorithm to create hash or to create a stamp in verifying to the recipient that the email was not spam. But in proof of work that is used by Bitcoin network, they are using SHA-256 algorithm, and for a valid to generate a valid hash of the block, that hash must start with a certain number of 0 bits, and the average work that is required to create that hash, a specific hash which start with a specific number of 0 bits, takes a lot of power to create that hash value or to get that hash value. But verification is very simple, because for verifying the hash, you just have to recalculate the hash of the block and match with the calculated hash. If both are same, you can verify it easily. Okay, how proof of work algorithms proceed? We can show it with this example. Okay, one thing that I want to show is that the algorithm in blockchain, this proof of work algorithm or proof of work or consensus algorithm, it is also called consensus algorithm. Okay, what is the purpose of this algorithm? This algorithm is used to confirm transactions and produce new blocks to the chain. So unless there is no proof of work or consensus algorithm has been run on the transaction, that transaction is not considered to be a valid transaction and will not be added into any of the block in the blockchain. So in order to make transactions actually happen, it has to be go through this proof of work or consensus algorithm. Okay, so this consensus algorithm, when it is being run, the whole process is known as the mining, and the nodes in the network that are participating in this mining process are called miners. Okay, how miners work? Miners, first of all, what they do is, we know that all the transactions are added into the memory pool. Like here, this memory pool has a lot of transactions into it. So miners will select some of the transactions from memory pool and create a candidate block out of it. Once a candidate block has been created by the miners, then miners add with it the block header. As I already explained to you, that block header has a version and bits and other information into it. So block header has been created out with this candidate block, which contains some information about the block or metadata about the block. Okay, now this the miner will take this block header and add with this block header a value that is called nonce value. Okay, we know that in the block header there is one field that is called nonce. So a nonce is first chosen randomly, and then a hash is created for this block header. On the only header of the block is used to calculate the hash of the block. Okay, then this block hash is compared against the target value. Like if our target is over here, and for this block header the hash of this block is greater than the target value, then it means this block hash is not a valid block hash. So what we have to do is we will increment nonce by 1 and then recalculate the hash of this block until we will keep on incrementing the value of nonce until we find the hash which contain a hash value less than the target. When you get a hash value less than the target, then that block is considered to be a valid block, and the miner who successfully find the nonce value which generate a hash less than the target value would be considered to be a winner miner, and that miner will be then rewarded with the incentive, okay, for in the form of transaction fee. And like now the reward for generating a new block in the blockchain is 6.25 Bitcoin. So he will be rewarded with this incentive in order to successfully get a new block in the blockchain. So once the miners find a eligible signature for its block first, that is the miner who find that nonce value which generates the hash less than the target value, then that miner will broadcast the block and its signature or its hash to all other miners in the network. When other miners verify the hash or signature legitimacy, here signature mean hash of the block, okay, if it is valid, the other miners will confirm its validity and agree that this block is a valid block, and now this block can be added into the blockchain. So after a block has been added to the blockchain, then every other block that is added will be on top of that block. So when your block is down in the blockchain, if it is more deeper, it has more credibility. It counts as confirmation for that block. So when a new block has been created, that doesn't mean that all the nodes in the network will come to know about that new block has been now added into the blockchain. Like right now, if this miner generate a new block, he will broadcast this block to all of its neighboring node, and then neighboring nodes will send to their neighbors, and eventually all nodes in the network will update their record with this new block. Like here in the blue color we show this new block. Initially it has been broadcasted over here to this network, this node broadcast to the neighbors, then this will broadcast to its neighbor, and eventually all nodes will get the copy of this new block that has been added to the blockchain. Okay, why do we use mining? What is the importance of this mining process, and what happened if we are not going to use this mining? So first thing is that because this system allow computer across a network to resolve conflict without the need for any centralized computer or centralized authority to resolve or sort out the conflict among them. You can see here in this example, like there is Bitcoin like runs across a network of independent computers, so it is possible to create two conflicting transactions, like sending the same Bitcoin to different places. Like, you know, you are a same person, you have the Bitcoin and you want to double spend them on two different things. Like let's assume Bob has some Bitcoins and he wants to buy, he first buy from that Bitcoin a drink and then burger. Okay, so transaction A where he use same Bitcoins to buy a drink, and transaction B he use same those coins to drink to get a burger. Okay, so there are two transaction A and B, and we consider them, these are conflicting transactions. Why conflicting transaction? Because they are double spending the same Bitcoins. So A will insert into the some nodes over here. These three nodes will get the information about transaction A, and these three nodes will get the information about transaction B only, and insert them into different nodes on the network at the same time. So like some nodes are receiving transaction A first and other nodes are receiving transaction B first. So but when mining has been done, so during the mining only one of the transaction will make it into the blockchain, and eventually one of the node on the network will mine a block of transaction from their memory pool. Out of these 1 2 3 4 5 6, maybe this node start mining process and he picks transaction B. Okay, he doesn't know about transaction A, so he picks transaction B and added transaction B in its candidate block, and then that block has successfully been mined by this miner. And once mining process finish, this miner will broadcast this new block to all the neighbors and neighbor to their neighbor, and eventually everybody will have this transaction B added into the blockchain, and transaction A have been lost. You know, it is automatically removed from the network, so nobody can perform double spending by using Bitcoin in this way. As we know that during proof of work, miners are rewarded with incentives that are in the form of Bitcoin plus transaction fee, and everybody wants to participate in this mining process because it is very beneficial for them, because they can earn a lot of Bitcoin by participating in this proof of work or mining process. But and by time, because we are increasing the hardware speed, so and people are more people are interested toward participating in the mining process, so it is possible to resolve the puzzle easily, because the puzzle is, or mathematical problem that has to be solved is to find such nonce value such that the hash of the block is less than the target value. So if we increase the hardware processing power, it means we can perform more number of hashes per unit of time, then difficulty will decreases over time. So this is what the author of, or the person who invented this Bitcoin doesn't want. They want that proof of work difficulty should remain consistent. Okay, so to compensate for this increasing hardware speed, and by adding, you know, more nodes into the network, the proof of difficulty is determined by a moving average target. I mean, it's not a fixed value, it always change as per the number of nodes participating in the network and what is their processing power. So what is a mining difficulty? We can define it as the degree which determine how hard it is for miner in terms of their hashing power to find a valid hash for the candidate block, so that they can win this competition of proof of work and can get incentive and add their block into the blockchain. Okay, here we explain it further that what is the concept of mining difficulty with respect to proof of work. As we know that a block is considered to be a valid block by the rest of the network if it has a hash. Now signature mean hash of the block. Okay, if it has a hash that start with a certain number of zero values which is less than our target value. So okay, the amount of zero that a signature require to start with determine how hard it is for miner. Like if there is more number of zero it start with, mining difficulty is higher. Okay, so this is called mining difficulty. Like here in this example we show different blocks, like block 5. Okay, each block have size almost 1 megabyte. In Bitcoin a size of the block is around 1 megabyte, including header and transaction information. Okay, like this block is we say block 5 and its size is 1 megabyte and it has some transaction data, plus it has the hash of the previous block which we call signature of block 4 because it is a block 5, and then some random nonce value. Like this nonce value will give it a valid signature, where this signature start with how many number of zeros? 2 2 2 and 1, 7. So total 7 signatures, 7 zeros. Okay, so block 6 also have this signature, but now when block 7 somebody wants to create a valid block 7, then miners has to find a random nonce value. When we perform hash on this block hash need to start with at least these many zeros that were in the previous, or maybe more. Okay, it depends on the mining difficulty. Now what is the mining difficulty? Very important concept. Okay, we define the mining difficulty is a number, okay, which regulate how long it take for miners to add a new block of transaction to the blockchain. And we know that we do not want our new block to be added into the blockchain before 10 minutes. Okay, not less than 10 minutes. 10 minutes is the maximum time. Like each block, a new block should be added into the blockchain after every 10 minutes. This is what Satoshi Nakamoto suggested, the one who is the author of this or inventor of this Bitcoin. This is what he suggested. Okay, and why it is 10 minutes we will discuss it in coming slides. Okay, why this difficulty is important? This difficulty is important because it make it sure that a block of transaction are added to the blockchain at regular interval, even if there are more miners join the network, because if you have more miners in the network it means that they can collide with they can you know, join their power with each other and they can get the valid hash more quickly. But we don't want our valid hash to come before 10 minutes. We want after every 10 minutes a new block should be added. So for this purpose this difficulty level is not a fixed thing. Difficulty is always, you know, a value that is adjusted regularly. Okay, so when we change the difficulty level, so difficulty adjust every 2016 blocks. Okay, how this 2016 blocks is being created? They said that after every 2 weeks, and we know that in 2 weeks you know, okay, how we get this 2016? We know that after every 10 minutes we want to generate one block. So in 1 hour we generate how many blocks? 6 blocks. And in 24 hours we generate 24 multiplied by 6 blocks, and in 2 weeks, that is 14 days, we multiply by it 14 and we get how many blocks? 2016 blocks. So difficulty changes after every 2 weeks or after every 2016 blocks have been generated. How difficulty is calculated? Difficulty is calculated like expected divided by actual. Now expected difficulty is that these 2016 blocks should be calculated in like one block in 10 minutes. So 2016 blocks should be calculated in 2016 multiplied by 10, 20160 divided by, and what is the actual? Okay, what is the actual? Let's suppose we are creating one block in 9 minutes. So how many blocks 2016 blocks we created in how many minutes? 18,144 minutes. Although our expected should be 2160, but we calculate it in less time because we are creating on average one block in 9 minutes instead of 10 minutes. So our difficulty now here we calculated as 1.11. So you calculate the difficulty like this, expected divided by actual, and then new difficulty is calculated by every miner by multiplying the old difficulty level with the one that you calculated over here with that value. Okay, like new difficulty will be old difficulty multiplied by whatever the expected divided by actual, that is 1.11. and if here this value, when you create this difficulty, if it is greater than 1, like here it is greater than 1, it means blocks are created more quickly than expected. Okay, so the next difficulty will increase. So we will increase the difficulty so that our block should be created every 10 minutes. But if this number is less than 1, it means that blocks are mined slower than expected, so difficulty will be decreases. Okay, here in this slide we present the relationship of target with difficulty. So let's suppose here, like in this first example, let's say I give you a range of number from 1 to 100, and now you are able to randomly generate a number between 1 and 100 once every minute. Okay, and your goal is to generate a number below my target number. Okay, so in the first here, my target, I set my target at here my target is at 100. So I want to ask you to generate a number below my target, and you know, in that case my difficulty is 1, because okay, the formula that is used to calculate target is target max divided by difficulty. So here target max is 100 and difficulty, because I am going to give you one chance for it to get this, so target max divided by difficulty. So for here it is 100, target is 100. Okay, now let's say I set the target to 50. Okay, I set my target at the value 50. So you are able to generate a number between 1 and 100 once a minute in 1 minute. So this should take you 2 minutes. So my difficulty now is 2. Okay, but now if I lower my target over here to 20, so in that case it means you are only going to be able to generate a winning number 1/5 of the time, or once every 5 minutes. So the lower the target, when target value become lower, the more difficult it gets to generate a winning number. Or when we say, if we increase the difficulty level, higher the difficulty level, the lower the target. Okay, so during proof of work, when mining process works, in mining process the basic aim of miners to find the nonce which generate a hash value of the block that should be less than the target value. Okay, we give them target, and target is set based on the difficulty. Okay, when it is more difficulty level is higher, then target is having a lower value. So it is more difficult to get the lower value when difficulty is higher. So here in this example we show that the difficulty that is discussed in the Bitcoin, it works exactly in the same way I described in the previous example. This difficulty is not fixed. After every 2016 block its value is adjusted. Okay, and it is used to set target value. because we do not want our block to be added into the blockchain before 10 minutes. So we set the target values, and miners keep generating numbers by hashing their candidate blocks. Like here, this is a candidate block, so miner will keep generating numbers in the hope that they will find a nonce value or a number that is lower than the target value. And as miners are able to generate like maybe a million or thousand of numbers of hash value per minute, so Bitcoin uses really a big numbers for target hash. And due to the fact that there are now thousands of miners trying to find this winning number, so to make sure that a winning number is found every 10 minutes, so the range of successful number ends up being absolutely tiny. Like here, you know, the difficulty level become more lower, it means it is more difficult to generate the target value. When target value is smaller, difficulty is higher. As you know, they have inversely proportional relationship between target and difficulty level. Okay, what is the reason that we do not want to generate a block before 10 minutes? Why only one block every 10 minutes should be generated? They said that, this is the answer over here, that blockchain need 10 minutes to propagate the latest block to all nodes globally, because you know this is a peer-to-peer network where nodes are scattered all across the world. So in order to propagate a block that is generated in America to the other end of the world, or from one end of the world, like a block is being generated in China and we have to propagate it to the other end of the world, like to America, let's suppose, it takes some time to propagate that block to all the nodes in the network so that everybody can get a copy of this new block, and it takes at least 10 minutes to propagate latest block to all nodes in the world. So that's why we want new block to be generated after every 10 minutes. Okay, what happened if blocks are produced before 10 minutes at a faster pace? Then what will happen as a result? There will be some nodes on one side of the world or one side of the globe may not be able to catch up with the late transactions data, because some nodes will have another copy of the block and some other, and it takes time to, you know, travel it to the other part of the nodes on the other part of the world. So it takes time to propagate it, and if we generate faster, then all nodes will not have a same data. There are some that have some other transaction data, and it generate uncle block. What is uncle block? Which is called chain split, which is basically something blockchain want to avoid at any level, so that to make this blockchain data consistent and secure. Okay, in the Bitcoin network, there are some steps that run in the network. First is, whenever a new transaction is being done by any node, it has to be broadcasted to all the other nodes in the network, and each node will receive this new transaction and added it into a memory pool from where it will create its candidate block. Then each node once create a candidate block, then that node will work on nonce, create a nonce and then increment it, like it goes into the proof of work. And once it is able to find the nonce which generates the hash of the candidate block less than the target value, then it broadcasts this block to all other nodes in the network, and other nodes in the network will accept this block only if it has a valid hash. Okay, and if all the transaction in it are valid and have not already been spent, double spend should not be there. So node then show or express their acceptance of the block by working on creating the next block in the chain. Like this block will be accepted as a valid block, and next block will be created on the top of it using the hash of the accepted block as previous hash into the new block. And there is a concept of longest chain in the blockchain, where nodes consider the longest chain always to be the correct one and will keep working on extending the longest chain. Okay, what is this longest chain concept? Here we discuss it. Okay, in this scenario we show that it is possible that two nodes are able to solve this mining problem at the same time. Okay, there are two nodes and both are representing their solution at the same time. Okay, so they both send their block as a valid block into the blockchain, like here we represent the with the color blue and green. So these two blocks are both valid blocks, and two nodes broadcast these two different version of the next block at the same time. So some node may receive this blue one, like this side, that is left side they receive blue one, and right side only receive the green one. So in that case they work on the first one they receive, like the one on right side they receive green, so they will keeps creating the next block on this green one, and the one who receive blue one, they will keeps creating the new block on the top of blue one. Now which one will be accepted, the green one or blue one? Now it depends on which next block will be added on, either a green one or blue one. Okay, like here in next slide we show. Okay, now which one is accepted? This tie will be broken when the next proof of work is found, like on top of which block the next block will be added. Like here on the top of green the next block has been added, but on the top of blue no next block is being added. Before on blue a new block should be added, it on green a new block has already been added on it. So this blue will be considered as orphan block. This blue will be considered as orphan block, and it will be removed from the blockchain, and all the transactions that are part of the blue they will not be considered a valid transactions. So here we show that maybe like we can see here in the previous, like half of the nodes consider blue as a valid and half of nodes consider this green block as a valid block. It means they were in disagreement in the blockchain for some time. This disagreement can occur for some time, but eventually because of the longest chain rule this disagreement will be resolved automatically, and node will always eventually agree on the same view of blockchain. So as we have seen in the previous example that this blue one, because of the longest chain rule, is not part of the network blockchain. Okay, and now it is a orphan block. So transaction which are inside this block are deactivated because of the chain reorganization, and because this orphan block is no more part of the transaction history of the blockchain. So any transactions that are part of orphan block is not now a part of the longest chain and are considered to be invalid transactions, and node will reject these transactions whichever are here in the orphan block. Why nodes reject the transactions that are here in the orphan block? Because it spends Bitcoin that are not in their longest chain. But if we look at this matter of the orphan block practically, they said that it is possible when two blocks are mined at the same time, then they are probably going to include the same transaction in them, because both blocks are created from the same pool of transactions. So it is highly likely that both these blocks, this green and blue, might have same copy of the transaction in them. So a reorganization is not usually going to cause any of a problem. Like if both have same transaction, so any one of the block added, that all the transactions become valid. But there is not a guarantee that if a transaction is not exist in the active chain, it may as well have never happened. Why? Because if there are some transactions which are in this blue block and not present in the green block, when blue block is not part of the blockchain, then these transactions will go back into the memory pool, and when a new block is being created, then these transactions can be again chosen from the memory pool for the next block, and they can be included in the next coming block. So that is not a big problem in Bitcoin network. Okay, as I told you that in Bitcoin network, during the mining process, miners, whoever generate a valid block, get an incentive. So this incentive is in the form of some bitcoins created as a result of this mining of a new block. Every time when a new block is created, a new bitcoins are added into the currency, because this is the way a new coin will be added. Okay, because there is no any central authority which is going to add a new coin into the Bitcoin. These new coin will be added into the Bitcoin by the mining process that we have already seen. So incentive is given in the form of these Bitcoin as a result of generating a valid block. Okay, the first transaction in a block is in every block. When a candidate block is created, a first transaction will be added by the miner who generate this candidate block, and this first transaction is called coin-based transaction, which start a new coin owned by the creator of the block. Okay, whoever create this candidate block, it will add a special transaction that is the first transaction in that block, and this transaction is called coin-based transaction, which include this the coin that is being earned by that miner if that candidate block will become a valid block. So miner use this coin base transaction to collect the block reward and any additional transaction fees. So incentive to the miners are in the form of block reward, which is currently 6.25 Bitcoin, and some additional transaction fee also. And as we know that once we have reached to 21 million of Bitcoins have already been created or in circulation, then incentive will only consist of transaction fee. There will be no block reward anymore. There will be no block reward. The only thing that will left with it is a transaction fee. But right now incentive is two things: block reward plus transaction fee. And block reward plus transaction fee is both things are added into the candidate block as a first transaction, which is called coin based transaction. And if this block become a valid block, then a miner will be rewarded with the money that is added here in this coin based transaction. Okay, what is a transaction fee and why it is important? Now transaction fee is the remainder of a Bitcoin transaction, and it acts as incentive for miner to include your transaction in their candidate block, because if there are more transactions in the memory pool, and we know that the block size is fixed to 1 megabyte, so a miner will choose or select transaction with high transaction fee. So if there are lot of Bitcoin transaction floating around the memory pool, like here there are lot of transactions, each transaction have different fee, so miner will choose wisely those transactions from the pool which have high fee, so they can get more incentive from these transactions. Okay, so as we know that Bitcoin block is limited to 1 megabyte in size, so transaction data, like almost for one transaction, if it is smaller one in the size, take around 250 bytes. So they will choose wisely from from this memory pool which transactions will be added into the candidate block based on their transaction fee. So if you want your transaction to be chosen by the miner in the candidate block, then you have to give or you have to provide higher or pay higher transaction fee for it, and these transaction fees are claimed by the miner through the Coinbase transaction, which I already discussed with you in the previous slide. Okay, proof of work or this consensus algorithm is really very time consuming and resource consuming algorithm, and there are some main issues, there are some other issues also related to this proof of work or consensus algorithm. The first one is the 51% risk. Now what is the 51% risk? It is said that if in the Bitcoin network, if there is some controlling entity who owns 51% or more than 51% of miners or nodes in the network, then that entity can corrupt blockchain by gaining the majority of the network. So in order to gain the majority of the network, attacker need to get at least 51% of the nodes in the network, then they can make changes into the blockchain which are not detectable. The other issue with it is that proof of work algorithm is time consuming, because miners have to check over many nonce value in order to find the valid hash, okay, value for the block, and it takes time. So it's a time consuming process. Also resource consumption, because miner are consuming high amount of computing power in order to find the correct nonce value or correct hash for the block. So it leads to a waste of precious resources like money, energy, space, hardware, everything is being used. And they said that it is expected like 0.3% of world's electricity will be spent to verify transactions of Bitcoin during this proof of work algorithm. And also transaction confirmation. Yeah, if you perform some transaction through Bitcoin, your transaction will be confirmed not immediately. Like on online banking, if you want to transfer a money from your account to another account, or if you want to pay your bill or anything, your transaction will be confirmed instantly, maybe after few minutes or maybe after few seconds. But in case of Bitcoin, if you are doing a transaction, it takes at least 10 to 60 minutes to confirm your transaction. It's not a instantaneous transaction. Why it's not a instantaneous transaction? Because of the mining process. It takes at least minimum 10 minutes, because mining process takes 10 minutes to add a new block into the blockchain, and when you perform your transaction, the chances that your transaction will be picked up by some miner and added into the block. So minimum value, because each new block takes 10 minutes, so minimum value time a transaction take is 10 minutes, and maximum maybe 60 minutes or more. Okay, this figure represent how a Bitcoin transaction works, with the information about wallets and addresses of the Bitcoin, then how to submit a payment, how transaction is being verified. All this information is given in this slide. It's really a detailed slide. I would suggest you to go through all of this scenario. I already explained everything in the previous slides for you about it. Okay, how do you can buy or sell Bitcoins? So you can buy or sell Bitcoins through different services like coinbase.com, circle.com, and some other. There are exchanges, money exchanges like normal frequent money exchange. So we have Bitcoin exchanges also available from where you can buy or sell your Bitcoin. Some of the very famous exchanges for Bitcoin are Bitfinex, BTC-E, or Bitstamp. And you can also individually can buy or sell Bitcoins through localbitcoin.com. Okay, Bitcoin wallet, like you keep your currency in a wallet, like physical currency in your wallet, and you put your wallet in your pocket or in your bag and everywhere. So where to store bitcoins? So in order to store bitcoin also we need a wallet, but Bitcoin wallet is a software. It's not like something tangible that you can see and look into your currency, but it's a software program where you store your bitcoins. If we look at it technically, then we can say that bitcoins are not stored anywhere. Actually, what bitcoins are, there is a secret number or a private key for every bitcoin address. Okay, and it is saved in the bitcoin wallet of the person who owns those bitcoins or that balance. So the Bitcoin wallet facilitates sending and receiving bitcoins and give ownership of the Bitcoin balance to the user. So if you have a Bitcoin currency, then you need to store it in Bitcoin wallet, and through Bitcoin wallet you can spend this money, you can send it to somebody, or you can receive from somebody your bitcoins. Bitcoin wallet come in different forms, like we have desktop, mobile, web, and hardware based Bitcoin wallets, which are main four types of the Bitcoin wallet. It is very important to keep your Bitcoin wallet safe. Why? Because they have your currency, digital currency, store into it, and it is like a very high value target for hackers. So it is your responsibility to keep it safe and secure with you. Some of the Bitcoin wallets that you can use, like for Windows, Mac, and Linux, for different operating system. Here is the list of the Bitcoin wallets that can be used on Android operating system. You can have KNC wallet, Bitcoin wallet, Hive. These are some of the Bitcoin wallet on Android. For iOS, we have these Bitcoin wallets softwares that are available. Similarly, if you want to use hardware based Bitcoin wallet, then we have these two, hardware and web based Bitcoin wallets. These are your list of some of the web based Bitcoin wallets available. Okay, there are not Bitcoin is not the one cryptocurrency that is available or that is being used in the world. There are many other cryptocurrencies also available. Like here we give some list of the cryptocurrencies that are currently being used in the world as a cryptocurrencies. Okay, here are some of the sources through which this lecture is being prepared, and if you want to get more information, you can go through these links. Okay, thank you so much.